Hi, welcome back. Or if you're new here, welcome to DataMindAI with Ahmed. I'm Ahmed Mahmoud, AI Solution Architect and Head of Data Engineering at DataMindAI. So this channel exists for one reason, to give you the production-grade AI architecture knowledge that most courses and tutorials skip entirely. So every episode in this series tackles a real layer of the enterprise AI stack. Not what the documentation say it does, but what actually does when your data is messy, your compliance team has questions, and your budget has limits. So today we are going to cover LLMOps and GenAIOps, which is the production AI operations layer. Now, and if you find our channel useful, subscribe and drop a comment with your toughest architectural question. I read every single one of them, so let us go. Welcome back to the AI Solution Architecture series. Today we are going to tackle what I call the invisible glue of production AI, LLM ops and Gen AI ops. So you have built your RAG pipeline. Your agents are working in dev. Your embeddings look great, but when you push to production and within 2 weeks answer quality degrades. So your retriever is drifting and you have no idea why. That is why the LLM ops problem. And today I'm going to give you a complete framework for solving it. From semantic evaluation and quality gates all the way through the CI/CD pipeline and deployment strategy built specifically for large language models. So this is episode number 5 of our series, sitting on top of everything we have built on the foundation, knowledge, intelligence, and automation layer. Let us go. Now, let us see what we can do here. Before we dive into implementation, let us get vocabulary straight because I see teams mix these up constantly. So we have this machine learning ops, which is MLOps, yeah, MLOps. Now, born in 2017 to 2019, it was designed for scikit-learn and XGBoost models. You know your loss function, you measure accuracy numerically, it is deterministic pipeline. Now, LLM ops, yeah, the challenge here is outputs are non-deterministic. Same prompt, same model, different response every time. So you cannot use MSE to measure quality. So you need semantic similarity, rubric-based gradings, and human evaluation at scale. Now, generative AI ops goes beyond single models to entire generative systems. So agents, RAG, multimodal, you are monitoring behaviors, not just outputs. Yeah. So if you apply traditional MLOps to LLM systems, you measure the wrong things. So you will deploy confidently and fail silently. Example, a team I know was measuring API error rate and latency only. Their LLM was answering questions correctly 6% of the time, but never erroring, perfect uptime, terrible product. Yeah. So how do you actually measure whether your LLM is working well? This slide is the answer. Number one is the faithfulness. The most critical metric is the answer. Is the answer grounded in what was retrieved? Yeah. So, so from where are you getting the answer? It's very important. So, are we from what we retrieved, or it's just hallucination that is? Yeah. So, we use RAGAS faithfulness, which checks every claim in the answer against the context. So, The target is always 90% in production. Relevance is the model answering the actual question. LLM loves to answer adjacent questions, so measure semantic distance between questions and answer. Context recall. This is often overlooked. Are you even retrieving the right chunks? So low context recall, which you call garbage in, garbage out. So no evaluation framework catches this without measuring it explicitly. So semantic similarity, cosine distance to a reference answer, no binary right or wrong, so captures partial correctness. The pipeline, never rely on a single evaluator. We use LLM-as-Judge, GPT-4 and Claudia grades with rubric, so RAGAS, automated metrics, and 10% human spot checks. The composite quality score threshold is 0.80. So below that, the deployment is blocked. The cost reality is running full eval on every deployment costs roughly 200 to 400 per run for a mid-sized system. So budget for it. Now, traditional CI/CD was built for deterministic software. AI is probabilistic, so we need to adapt the pipeline. So prompt our code. I cannot stress this enough. Every prompt change, every RAG configuration change, every agent system prompt update, that is a code change. It goes through pull request, code review, and automated testing. For example, now you have the commit unit test. Mock the LLM response. Don't call the actual API in continuous integration or CI. It is too slow, too expensive. Use response fixtures. So test that your prompt templates compile, that your RAG retrieval logic runs, that tool calls are structured correctly. So the eval gates, this is where real LLM calls happen. Full RAGAS suits against your golden test set. Quality threshold 0.80. This is this gates cannot be bypassed. I have seen teams add emergency override switches. Don't. So the whole point is that it cannot be bypassed. So staging is like 5% canary. Shadow mode means to the old model handles real traffic, but the new model processes the same inputs in parallel for comparison. No user impact, real production data. So in the prod blue-green deployment, you maintain the old version running until the new one is verified healthy. So automated rollback is under 2 minutes. And the cost check is full evaluation pipeline should run in less than 30 minutes and end-to-end to support rapid iteration. Your model was great last month. Why is it struggling today? Drift is why. 3 types of drift, and you need to monitor all 3. So data drift, the question users ask is change over time. If you build a student support system in September, and by January, students are asking completely different questions like exam prep versus coursework, your retrieval pipeline might not be calibrated for the new distribution. Now, monitor query embeddings. If the centroid shifts, investigate. Now, the model output drift. The LLM provides updates their models. GPT-4, for example, Turbo 2024-04, 09, this 0125 behave differently. Monitor output characteristics, response length, citation frequency, refusal rate. If this shift, your model changes under you, of course. So the third is concept drift, the hardest one to find. The world changes, and a regulatory update means the correct answer is what are the requirements for X. changed, only the catchable through the downstream's KPI monitoring and periodic human evaluation. So in real example, I worked with a team whose RAG system served knowledge base. They noticed the customer satisfaction dropping 8 points over 6 weeks. The root cause was their knowledge base vendor updated document formats, breaking their chunking strategy silently. Data drift caught it in retrospect. No monitoring caught it in real time. So the detection threshold guidance, which is KL divergence is greater than 0.15, yellow alert investigation within 24 hours, PSI is greater than 0.2, orange alert investigate within 4 hours, quality score is less than 0.75 for 24 hours, PI wake someone up and do something. So that's the quality gates are the enforcement mechanism. Without gates, you have guidelines. With gates, you have governance. Yeah. So gate one, pre-deployment. This is the CI/CD eval gate we discussed. It is automated. It runs in the pipeline. It blocks no exceptions. Even a hotfix or a bug must pass quality evaluation. Why? Because I have seen emergency hotfixes break quality while fixing bugs. So gate number 2 is canary, 5% of live traffic for 30 minutes, real users, real queries, but limited blast radius. If latency spikes or quality drops, automatic rollbacks. 30 minutes is enough to catch most issues without significant user impact. So gate number 3 is a post-deployment confirmation. The 24 hours window matters because some issues only surface with real usage patterns. So overnight traffic behaves differently from peak hour days. So day one post-deployment is when you are on alert. Gate number 4, weekly health check. This is not deployment gate, it is drift detector. If quality is the trending downward 2 to 3% per week, you need to retrain or retune before it hits a critical threshold. Now, scorecard call out. Look at the right side. Context recall at 76% is below target. Hallucination rate at 6.2 is above acceptable. In real production system, this would have triggered a P1 investigation. This is the power of having clear threshold. Now, knowing when to use which deployment strategy saves you from production incidents. Yeah. Now you have this blue-green classic zero downtime deployment. Yeah. The catch, it doubles your infrastructure cost during the cut-over window. So for LLM specifically, this means you have 2 full serving stacks running simultaneously. So if you are on Azure AI Foundry, that is 2 separate endpoints deployment, worth it for major releases. Now the canary one is my default recommendation for most LLM changes. It is 5% evaluate and 10% evaluate and then full one. So the gates between expansion steps are automated. Your monitoring system decides whether to promote. So build this automation before you need. So shadow mode is the fastest strategy, but expensive. Every inference runs twice. Use this for high stakes model change, new base model, significant prompt engineering. Now, future flags. Underused in AI systems, if you are adding a new capability, say adding code generation to support BotGate, it blends a flag, roll out to your team first, then power users, catch edge cases before full rollout. So decision framework, I put this at the bottom of every deployment planning document where quick reference prevents the just push it mentality. And then you have the rollback time target, whatever Whatever strategy you use, automated rollback should complete in under 2 minutes. If it takes longer, you are losing users and you are making on-call engineers' life miserable at 2 a.m. Now, let us bring all of this together into a coherent architecture. So we have, again, here 3 pillars. Yeah, we have the development, operation, and observability. Yeah, this is intentional. So DevOps engineers think in these 3 dimensions, which is you have development, operations, and then observability. Yeah? And I'm arguing that all AI systems need the same discipline. Now, the development layer, this is where you author prompts, build chains, test locally. The key addition is with traditional software development is the local eval harness. So you should be able to run a subset of your test suite locally before pushing a commit. So again, let me repeat here. So because there is a difference between the traditional software and this key and this AI side to it. So the addition for the traditional software is for AI, you need this local eval harness. So you should be able to run a subset of your test suite locally before pushing a commit. Yeah. So this kind of discipline is not part of the traditional software development. Now, operational layer, this is the automation layer, your CI/CD pipeline, canary controlled model registry. So the model registry is critical. It tracks which prompt template version, which embedding model version, which LLM model version is deployed where. So without it, you cannot reproduce incidents. Yeah? Again, observability layer, Langfuse is my open source recommendation for LLM observability. Phoenix from Ariza is excellent for RAG specific monitoring. On Azure, Application Insight handles the traditional telemetry, but you'll want the AI specific metrics layered on top. Now, tooling philosophy, start with open source, upgrade to enterprise when you hit scale. Don't let vendors lock you into proprietary evaluation framework before you understand your own quality requirements. Now let's land the plane. 5 things to take away from today. Number 1 is prompts are code. Yeah, treat them that way, full stop. So the prompt should be treated as code. Number 2, evaluate on 4 metrics with a composite quality score of 0.80 as your production threshold. Don't deploy below that. So the 4 metrics as critical, and then the quality score of 0.80 as your production threshold. And if you don't reach that one, don't deploy below that. Yeah. So number 3 is monitor 3 types of drift. Set your threshold before go live, not after your first production incidents. Yeah? Number 4 is 4 quality gates, each with explicit threshold and automated action. Gates without automation are just suggestions. Yeah. Number 5 is pick the right deployment strategy for the risk level. Canary for most changes, shadow for high stakes, blue-green when you need 0 downtime. So if you implement just these 5 principles, you will catch 80% of production AI failures before they impact users. In the next episode, we are going to cover protection layer, guardrails, PII detection, prompt injection defense, and how to meet GDPR and other requirements. So subscribe so you cannot miss one of them.